Hello everyone. In previous lecture, we have studied the definition of unilateral Z-transform and the unilateral Z-transform for some typical signals, and the properties of unilateral Z-transform. In this lecture, we will study the inversion of unilateral Z-transform. This is the definition of inversion Z-transform. Direct inversion of the Z-transform is complicated. We can determine it by using the one-to-one relation between a signal and its unilateral Z-transform. There are two methods. One is power series expansion. Another is partial fraction expansion. First, we will discuss the power series expansion. X of z can be expressed in this equation. When the x of z is expressed as a power series in z sup minus 1, the values of the signal are then given by the coefficient associated with z minus k. Then we can get the signal x of k. This inversion method is limited to find the finite values of x of k. For example, determine x of k according to this x of z and its ROC. We use long division to express x of z as a power series in z sup minus 1. This is a long division process. X of z can be expressed in this equation. So we can find x of k is in this result. Obviously, this method may not lead to a closed form expression for x of k. Now we will study another method, partial fraction expansion. In most cases, we frequently encounter Z-transforms that are a ratio of polynomials in Z or in Z sup minus 1. X of Z can be expressed in this equation. We can use the partial fraction expansion to express x of z as a sum of terms. We have now these signals unilateral Z-transforms. For example, determine x of t according to the x of z and its ROC. X of z is an improper rational fraction. Its poles are distinct. If possible, factoring z in the numerator polynomial, then do partial fraction expansion. Factoring z in the numerator polynomial. Here, x1 of z is a proper rational fraction. Do the partial fraction expansion, we can get the coefficients a and b. We can get this equation for x of z. And then we can get x of k by inversion of unilateral Z-transform. This uk corresponding to this fraction. This exponential signal corresponding to this fraction. Here is another example. X of z is a proper rational fraction, and the pole 1 is repeated twice. First, factoring z in the numerator polynomial. Here, x1z is a prop rational fraction. We can get its coefficients a, b, c for x1z. So x of z can be expressed in this equation, and we get its signal x of k. This signal corresponding to this fraction, this signal corresponding to this fraction, and this signal corresponding to this fraction. Here is another example. X of z is an improper rational fraction. Its poles are 3 and 4. Firstly, we need to get the part of the proper rational fraction. By long division, we can get this x1 of z. It's a proper rational fraction. According to these coefficients, we can get x of z. According to this relation between signal and its unilateral z transform, we can get the signal for this x of z. In this lecture, we have studied the inversion of unilateral z transform. That's all for today. See you later.